balanced and active community and strong businesses. Our topic is today applications of mathematics in daily life. Math is very useful in everyday life. Maths can help us to do many things that are important in our everyday lives. Mathematics makes our life orderly and prevent chaos. Experience says learning mathematics can be made easier and enjoyable. If our curriculum includes mathematical activities and games, mathematics offer rationality to our thoughts. It is a tool in our hands to make our life simpler and easier. Now, let's take a moment to introduce our guest speaker to you all. Dr. Parveen Kumar Sharma is Associate Professor of Mathematics in Sri Sai Vaishnav Institute of Science. He has a 19 years of teaching experience
Sorry, ma'am. Sri Vaishnav Vidyapeeth Vishwavidyalaya.
Okay, sir. And received 10 awards such as an Outstanding Scientist Award for Scientific Innovation awarded by GEI India, International Education Excellence Award in 2021 in Mathematics, Eminent Scientist Award, Best Senior Scientist Award, and Best Academian of the Year 2022. Before starting with today's event, there are some ground rules which the participant needs to be obey and follow them. Feel free to drop your questions in the chat box. We will answer every question in the end. Every participant is requested to keep their mic mute. And third last, a feedback form will be shared in the chat box. Now, over to you, sir.
Thank you, ma'am. Thank you for introducing me nicely. I'm going to start my slide.
Sure, sir.
I have shared my screen. Is it visible?
Not yet, sir.
Now. Is it visible?
No, sir.
No, we are not getting. We are not seeing your.
Just a bit. Yes, I have shared it now. I think, is it visible now?
Nice.
Yes, sir. Yes.
Okay. Want to fit it? Yes. Is it clearly visible now?
Yes, sir.
Yes.
Okay, thank you. Let's start a talk on application of mathematics in daily life. There are a number of applications of mathematics in almost all areas of engineering, science, technology, and business management. It is a generator of almost all the subjects. It is a foundation of all subjects. Nothing can be done without having basic knowledge of it. So it is must to have basic or elementary knowledge of mathematics so that one can easily do their job without facing any difficulty. As I just mentioned that there are a number of applications of mathematics. It's very tough to discuss all applications in short duration, that is in an hour. So I will be focusing on applications of mathematics in particular areas like set theory, differentiation, integration, statistics, operation research, mathematical modeling, and ordinary differential equation. Application of mathematics in set theory. In our daily lives, we often use words such as a bunch of keys, a pack of cards, a class of students, a team of players, etc. The words bunch, pack, class, and team all denote a collection of several discrete objects. And a set is any well-defined collection or class of distinct objects. The following are some of the examples of the set. Rivers in India, it is a well-defined collection of objects, so it is a set. Countries in the world, the planets, sun, moon, and earth, etc. All are example of set. Every collection is not a set. For a collection to be a set, it is must be well defined. For example, A is the collection of any 5 positive integers, and B is the collection of first 5 even positive integers. The collection A is not well defined because the positive integers, say 4, may or may not belong to A. On the other hand, collection B is well defined because the numbers of the collections are 2, 4, 6, 8, and 10, and therefore the collection B is a set. Actually, there are a number of applications of set theory. One of them is in decision making or in principle of inclusion and exclusion. The number of elements in finite sets such as A union B, A intersection B, A direct sum B, etc. are obtained by including as well as excluding certain terms. This method of finding the number of elements in a finite set is known as principle of inclusion and exclusion. We have principle of inclusion and exclusion from 2 set to 5 set. Here, this is an example of principle of inclusion, statement of principle of inclusion and exclusion for 3 sets. Let A, B, and C be any 3 sets. So then, cardinality of A union B union C is defined as cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B minus cardinality of A intersection C minus cardinality of B intersection C plus cardinality of A intersection B intersection C. We can expand this principle for 4 set and for 5 sets also. For example, here data of 100 students, data of those 100 students who study maths, physics, bio are given. That is, this is the mixed data. In this, from the help of this data, we have to find out the students studying all the 3 subjects, and we have to find out the number of students studying exactly one of the 3 subjects. I read among 100 students, 32 study maths, 22 study physics, 45 study bio, 15 study maths and bio, 7 study maths and physics, 10 study physics and bio, and 30 don't study any of the 3 subjects. Then find the number of students studying all the 3 subjects. Find the number of students studying exactly one of the 3 subjects. So here, by applying the concept of principle of inclusion and exclusion for 3 finite set A, B, and C, we can find out the answer of both part of the question. That is, we can find out the number of students studying all the 3 subjects and number of students studying exactly one of the 3 subjects. Next, application of mathematics in relation and functions. First of all, here I want to discuss definition of function. Let A and B any 2 non-empty sets. If there exists a rule F which relates each element X of A to a unique element Y of B, then such a rule is called a function or mapping from A to B. Application of function, for example, let capital A be the set of books in library and capital N be the set of natural numbers. Let F be a rule which assign to each book the number of pages contained in it. Therefore, F is a function from A to N. Similarly, allotment of roll numbers to the students in any exam is also an example of function. Next, application of relation. This is the definition of relation. The relation such as less than, perpendicular to, not equal to, subset of, etc. are often used in mathematics and computer science problems. Let U be any universal set. Here, this is the definition of relation. Let U be any universal set, and capital A and capital B are 2 subsets of U. Any subset of Cartesian product of A and B. This is the Cartesian product of A and B, denoted by A cross B, is called a relation from A to B. Any subset of Cartesian product of A cross A is called a binary relation on A. Oh, this is an example of relation. Suppose we want to find out the last digit of 7 to the power 73. It's very tough to find out the last digit of 7 to the power 73 manually. But by taking help of relation, we can find out the last digit of this term easily. By applying the concept of congruent relation with respect to modulo 10, one can easily find out the last digit of the asked term, which will be 7. This is the working procedure. That is how we find out the last digit of the term 7 to the power 73. Similarly, if we want to find out the last two digits of the term, so then we take modulo 100. By taking modulo 100, we can find out the last two digits of the any term. Next application. Application of mathematics in differentiation. And application of differentiation here in maxima and minima for finding out maximum profit or minimum cost or optimum solution of any problem. For finding out maximum profit or minimum cost or optimum solution of any problem. For example, a rectangular box open at the top is to have a volume of 32 cubic centimeter. Find the dimensions of the box requiring least material for its construction. So here we have to apply the concept of maxima and minima. By applying the concept of maxima and minima for 2 and 3 functions, we can get dimensions of the box, that is length, width, and height. That is X, Y, and Z. In business and banking, the total revenue in rupees received from the sale of X units of a product is given by Rx is equal to 3x square plus 36x plus 5. Then find the marginal revenue when X is equal to 5. So here we have to find out marginal revenue at X is equal to 5. X is equal to 5, whereas the revenue in rupees given, that is value of Rx is given. We have to find out the marginal revenue. So for finding out the marginal revenue, we have to do the differentiation of the equation Rx is equal to 3x square plus 36x plus 5 with respect to X. Then we have X is equal to 6x plus 36. Find the value of this term at X is equal to 5. Then we have there upon dx is equal to 6 into 5 plus 36 is equal to 66 in rupees. So it was the application of differentiation in business and banking. Next, application of mathematics in integration. So for finding out length, surface area, and volume, for finding out area of any colony, for finding out volume of any water tank, finding out surface area of any solid, the use of integration. Next, application of mathematics in statistics. Application of mathematics in statistics. In mean, median, and mode. Application of mean in finding out an average of any vehicle. For example, average of car, truck, tractor, bus, etc. For finding out an average speed of the vehicle to cover the total distance in X time, and an average number of hours required to cover the whole syllabus of the subject. Application of mode in supply and demand is a, for example, keeping maximum store of 8 number size shoes by an owner of a footwear showroom, and keeping maximum store of 39 number size shirts by an owner of the store. Application of mathematics in operation research. How to use of minimum available resources. How to use of minimum available resources in a optimal manner so that maximum target can be achieved or maximum benefit can be obtained or maximum profit can be achieved, maximum profit and minimum cost. So this is the definition of operation research, or in different way we can say that an art of winning the war without actually fighting it or without actually involving in it is a operation research, or it is a strategy management, right? There are a number of applications of operation research, but due to shortage of time here, I am taking only 2 applications of operation research, one in assignment problem and second one in transportation problem. Assignment problem means how to assign jobs to the workers or how to assign workers to a machine. For getting the result of this task, we apply the concept of assignment problem. Here, this is an example how to assign 4 jobs to 4 workers, or how to assign 4 workers to 4 machine so that maximum profit can be obtained. Data in tabular form is given. Jobs are given horizontally and persons are given vertically. This is the data. 6315669544773. So here, by applying the working procedure of Hungarian method, we can find out the optimal assignment or optimal solution of this problem. That is, which person should be assigned to one of the 4 jobs, right? So by applying working procedure of Hungarian method, we can find out the optimal solution of this problem. Here in traveling salesman problem, that is with respect to shortest route, minimum time, area, minimum cost, max profit. And this is the traveling salesman problem. Salesmen and districts are given. There are 5 salesmen and 5 districts A, B, C, D, E. We have to assign salesmen to the districts. There are 5 sales area or 5 sales district and 5 salesmen. Our main task is to assign salesmen. We have to send salesmen to the suitable district so that we can get a maximum result or maximum output, that is maximum profit or minimum cost, or we can find out shortest route, or we can find out minimum time, or we can find out max area, or indirectly we can say that they can cover maximum area. Salesman can cover maximum area. So here, by applying again the concept of Hungarian method, by applying the working procedure of Hungarian method, we can find out the solution of this traveling salesman problem. Here, this is an example of transportation problem, that is application of operation research in transportation problem. That is how to transport products or goods in an optimal manner to warehouses, factories, or destinations. So this is the transportation problem. Find the initial basic feasible solution to the following transportation problem by northwest corner rule and WCR. This is the data. Here are 3 factories and 4 warehouses, W1, W2, W3, W4. And in last column, that is 5th column, capacities are given, and in last row, that is 5th row, requirements are given. Again, by applying the working procedure of northwest corner rule method, we can find out the optimal solution of this transportation problem. Next, we come to application of mathematics in mathematical modeling or through mathematical modeling or ordinary differential equation, or application of mathematical modelings or ordinary differential equations. For finding out solution of any real life problem or physical problem, first of all, we convert the given physical problem into mathematical problem, or we do the mathematical model, of the given problem. Thereafter, we go further for finding out the solution of the problem. This is the basic rule, basic funda, that is for finding out the solution of physical problem. First of all, we convert that problem into its mathematical form, that is in mathematical problem, or we do the mathematical modeling of the given problem. Thereafter, we go for finding out the solution of the problem. For example, to find the height of a tower, to find the height of a tower, particularly when it is not possible to reach the top of the tower. So from our knowledge of trigonometry, we know that if we have an angle of elevation and the distance of the foot of the tower to the point where we are standing, then we can calculate the height of the tower. And it will be h is equal to d into tan theta by taking help of Pythagoras theorem. S denotes the height, d denotes the distance, and the angle of elevation is denoted by theta. Next, to find the width of a river. Suppose we want to find out the width of a river where it is difficult to cross the river. So again, we have to take this concept. We have to take help of this concept, that is help of mathematical modeling, and then we can easily find out the width of a river. Many practical problems in science and engineering are formulated by finding how one quantity relates to one or more quantities defined in the problem. To describe, understand, and predict the behavior of a physical system, a mathematical model is constructed by relating the variables through one or more equations. These equations describing the system in motion are differential equations involving the derivatives which measure the rate of change. The only thing that is constant in the physical world is change. Differential equations are important because they express relationship involving the rate of change. These relationships form the basis for studying the phenomena in various fields of science and engineering. Many practical laws are expressed mathematically in the form of differential equations. The primary purpose of differential equations is to study how the physical world changes. How the physical world changes. This is the definition of differential equation. An equation which contains derivatives of one or more dependent variables with respect to one or more independent variable is called a differential equation. Differential equations are classified into two categories, ordinary and partially, depending on the number of independent variables contained in the equation. Ordinary differential equation. A differential equation which contains ordinary derivative of one or more dependent variables with respect to only one independent variable is called an ordinary differential equation. Whereas the differential equation which contains partial derivatives of one or more dependent variable with respect to two or more than two independent variable is called a partial differential equation. But here I am focusing on ordinary differential equation. Here I am taking application of ordinary differential equation only. Order of any differential equation. The order of a differential equation is the order of the highest derivative which occurs in it. For example, in the differential equation d2y upon dx2 minus 4y is equal to 0. Highest order derivative is, this is the highest order derivative, that is d2y upon dx2. So order of this differential equation is 2. And in equation number second, dqy upon dx3 plus 6 d2y upon dx2 plus 11 dy over dx plus 6y is equal to e to the power 2x. Highest derivative of equation second is highest derivative is dqy over dx cube. So order of this differential equation is 3. Order of this differential equation is 3. Similarly, the order of equation number 3 is 2, and order of equation number 4 is also 2. So equation first, third, and fourth are each of order 2. Equation second is of order 3. How to form the differential equation from a given curve or given physical problem, or how to do a mathematical modeling. We will understand, we will discuss this concept by taking this example. Form the differential equation from the family of curves y is equal to mx, where m is arbitrary constant. Form the differential equation from the family of curves y is equal to mx, where m is arbitrary constant. Here we have to form the differential equation from the family of curves y is equal to mx, where it is given that m is arbitrary constant. So for forming the differential equation for this curve, first of all, we do the differentiation of this curve y is equal to mx with respect to x, and we get the value of dy by dx, which is equal to m. So now here in equation number second, we have the value of m is equal to d2y upon dx, sorry, dy over dx. Now put this value of m here into equation number first, y is equal to mx, then y is equal to x into dy upon dx. Do it simplify, x dy upon x dy over dx minus y is equal to 0. Now this is the ordinary differential equation or mathematical model of this given problem, or mathematical modeling of the given problem. How to form differential equations from a given curve or given physical problem, or how to do a mathematical modeling. Here it was the equation of the curve with only one constant coefficient, but here this is the equation of the curve y is equal to a sine x plus v, which contains two constant coefficients, that is a and v. So that is, if the family of curves, or if the equation of curves contains two constant, then how to find out the, or how to form the differential equation, or how to do the mathematical modeling. So in such case, we do the differentiation of given family of curves twice, and then we go for eliminating the arbitrary constants from the given equation and from the equations that we get from the successive differentiation of this equation of the curve. That is, by eliminating a and b from equation first, second, and third, we will be getting the differential equation for this family of curves. Given equation of family of curves y is equal to a into sine x plus v, do we differentiate with respect to x, or differentiating first with respect to x, we have dy upon dx is equal to a into cos of x plus v. Again, on differentiating second with respect to x, we have d2y over dx2 is equal to minus a sine x plus v. This is the equation number third. Now, eliminating a and b from first, second, we have d2y over dx2 is equal to minus y, or d2y over dx2 plus y is equal to 0, which is the required ordinary differential equation or mathematical model of given problem. Next, parachutist problem, application of mathematics or application of first order ordinary differential equation in daily life, that is parachutist problem. This is the parachute, and this is the parachutist who is coming down, right? Who is coming down. Then when parachutist comes down, then two forces act on that. Two forces act on that. The attraction by the earth, mg, where m is mass of person plus equipment, and g is acceleration of gravity, which is by 9.8 meter per second square, or value of g is 9.8 meter per second square. And the ER resistance assumed to be proportional to the square of the velocity Vt. Then by Newton's second law of motion, we know that force is equal to mass into acceleration, and value of this force will be equal to mg minus bv square. Mg minus bv square is equal to m into a. A means acceleration, which is given by dv upon dt, or d2a, or d2 by upon dt square. This is the velocity. When we do the differentiation of velocity with respect to time, then we get acceleration. So m into dv upon dt. Do it simplify. On simplifying this result for the value of dv upon dt, we get dv upon dt is equal to g minus b over m into v square, or dv over dt is equal to b over m within a bracket k square minus b square, where k is equal to gm over v is equal to constant, and v is equal to 50 nano second square per meter square, which is equal to coefficients of resistance of parachute, which is the required differential equation. On solving this differential equation, we get the value of v at time t. On solving this differential equation, we get the value of v at time t. Okay, means at particular time t, if we want to find out the velocity, then by taking help of the solution of this differential equation, we can find out. We can find out the value. Or on integrating this differential equation twice, we get the value of y. We get the value of y, and here y is the position vector of the parachutist. So what will be the position of parachutist at particular time t? So that can also be obtained by taking help of the solution of this differential equation. Thank you. It's enough for a day.
Thank you, sir. I ensure the seminar will be profitable and fruitful for everyone present here. Sir, there are a few questions which our audience wants to be answered. So with your permission, shall we?
Yeah.
Sir, why mathematics is important in our daily life?
Actually, nothing can be done without having the basic knowledge of mathematics. For finding out the solution of every problem, for finding out the solution of every physical problem, first of all, we do the mathematical modeling of that problem, right? So without doing the mathematical modeling of that problem, nothing can be done. The solution can't be found out. So this is the reason, this is why mathematics is very important in our daily life.
Okay, sir. So second question is, what is the use of relation function in last digit if we know the cyclicity of the number?
If we know the
Cyclicity of the number.
repeat please.
Yeah, sure, sir. What is the use of relation function in last digit if we know the cyclicity of the number?
Use of relation and function for finding out the last digit or last two digit is actually, this is an example of congruent relation. Congruent relation, right? So here we have applied the concept of A congruent to B modulo M. A congruent to B modulo M means that if we subtract B from A, then definitely A minus B uh, will be A minus B will be divided by, if we divide A minus B by M, then we get a perfect number. Right. So by taking help of this relation, congruent relation, A is congruent to B modulo M, we can find last digit or last two digit or last three digits.
Okay, sir. So third one, we differentiate the function. Can't we do it without differentiation? Just putting the value of x. I repeat, we differentiated the functions. Can't we do it without differentiation? Just putting the value of x.
Actually, differentiability and continuity and differentiability are connected with each other. Actually, continuity is the necessary condition for the function to be differentiable. Continuity is the necessary condition for any function to be differentiable. If function is not continuous, then we can't differentiate it. All right. So continuity is the necessary condition for function to be differentiable. For example, fx is equal to x. Fx is equal to mod of x. This function is continuous at x is equal to 0, whereas it is not differentiable at x is equal to 0, as because we get two tangent at x is equal to 0, one with 45 degree and second one is 135 degree. So if we put the value of the function, then we get different results. So nothing can be said, on putting the or on checking the value of the function at point.
Thank you, sir. Sir, can you repeat the parachute problems?
Parachutist problem. Yeah, sure,
Yes,
sure.
indeed.
Yes, this is the parachutist problem. This is the parachute. And this is the parachutist. This is parachute and this is the parachutist. When parachutist comes down, then two forces act on that. It is parachutist. This is the parachutist who is coming down, right? When parachutist comes down, then two forces act on that. The attraction by the earth, that is mg, towards the earth. Attraction by the earth, mg, where m is the mass of the person plus mass of equipment, and g is acceleration of gravity, and everyone knows that value of g is 9.8 meter per second square. And the air resistance acts upward direction, means opposite to mg. Okay. And the air resistance assumed to be proportional to the square of the velocity vt. So then by Newton's second law of motion,
Sir, your screen is not visible.
Just please, it happened due to low network activity. Want to share it again? Please give me a time.
Okay, sir.
I think it is visible now.
Yes, sir.
Okay. So mg minus bb square is equal to m into db upon dt. db upon dt is equal to g minus. On simplifying this equation, for the value of dv upon dt, we get dv upon dt is equal to g minus b over m into v square, which implies that b upon m k square minus v square, where k is equal to gm by gm over v is equal to constant, and b is a coefficient of resistance of parachute, which is value of v is 50 newton second square per meter square, which is the required differential equation for finding out the velocity. Okay. Any other question, please?
Okay, sir. No, sir. Thank you, sir.
Okay.
Now I would like to request everyone to kindly open their camera for a snapshot. We are happy to provide additional support to you. Feedback link is being already added in the chat box. Please fill this form, and thank you all for joining. Thank you, sir.
Thank you, ma'am. Thank you, organizers, for giving me opportunity as a speaker. Thank you.
Thank you.